We're going to find the center and radius of the sphere given by x squared plus y squared plus z squared plus 8x minus 6y plus 2z plus 17 equals 0. It would be nice if our x squared and our 8x were combined, and then we could complete the square. Remember, we're looking for an equation of the form x minus h the quantity squared plus y minus k the quantity squared plus z minus l the quantity squared is equal to r squared. What I'd like for you to do is go ahead and pause the video, complete the square on x, y, and z, and come up with the answer to the question, which is the center and the radius. Gathering together the x's, we have x squared plus 8x. Completing the square there, we divide 8 by 2 and then square it. The result is 16. We add 16 to both sides. Likewise, y squared minus 6y. Cut the 6 in half, square it. We get plus 9 on both sides. And finally, for z squared plus 2z, we're adding 1 to both sides. And the factoring is x plus 4 the quantity squared plus y minus 3 the quantity squared plus z plus 1 the quantity squared is equal to 9. Remembering that we change the sign on what's in parentheses when we are finding things like a center of a radius or the vertex of a parabola, we get that the center is -4, 3, -1, and the radius is the square root of 9, 3. Next up, we're going to find the equation of a sphere if its diameter has endpoints 5, 4, 3, and 1, 6, -9. Now we know that the center is going to be the midpoint of the diameter. And the midpoint formula in R3 is what you would expect it is. x1 plus x2 over 2, y1 plus y2 over 2, and then we bring in the z coordinate, z1 plus z2 over 2. Now, it may be a while since we found some midpoints, and so what I find in 5C is sometimes, well, you know what, I find it in just about every class. Sometimes folks have the wrong formula. They'll put differences, like they'll put x2 minus x1. And that's appropriate for the distance formula, but and for a slope, for instance. But for a midpoint, remember that it's the average of each of the coordinates, right? So here we have as our center 5 plus 1 over 2 for the x's, 4 plus 6 over 2 for the y's, and 3 minus 9 over 2 for the z's. That'll give us the point 5, nope. That'll give us the point 3, 5, -3. As for the radius, what I'm going to do is I'm going to use one of the given points, 5, 4, 3, and then I'm going to use the center that we just found, 3, 5, -3. And we're going to use the distance formula between these 2 points, but we're kind of tweak it a little bit. The equation for the sphere that we're after is x minus h the quantity squared plus y minus k the quantity squared plus z minus l the quantity squared is equal to r squared. Now, I'm sure you remember that. I'm not repeating that for you, really, but what I'm trying to say here is we have a point on the sphere, 5, 4, 3. And so those coordinates go in place of x, y, and z in the equation for the sphere. Likewise, for our center, we have 3, 5, and -3. And we can just continue to flesh out the equation of the sphere, remembering that each of those is going to have a change in sign. And so we end up with 5 minus 3 the quantity squared, plus 4 minus 5 the quantity squared, plus 3 plus 3 the quantity squared, changing the sign on that -3, is r squared. Simplifying, and you can check this, gives us that r squared is 41. What about the distance, though? Well, it's the square root, but we don't need it. We're looking for the equation of a sphere, which contains r squared. And so we're going to rewrite what we have. X minus 3 the quantity squared plus y minus 5 the quantity squared plus z plus 3 the quantity squared is equal to 41, and we found the equation that we were looking for. And I realized I circled the center. Didn't need to. That wasn't what was being asked. Now, one of the things that folks often do is they'll take the endpoints of the diameter, they'll find the distance between those two, totally fine, and then they'll botch it when they put it into the equation of the sphere because they forget that the diameter divided by 2 is the radius. And when we square that, we should have that the radius squared is the diameter squared over 4. And that's something that just gets in a lot of people's way. So I recommend that you just go to the equation of the sphere, use one of the endpoints of the diameter, and then use the center that you've already found. So I would say find the center and then use the center. Next up, we're going to go in a fairly different direction here. Describe what is represented by x squared plus y squared equals 4. And you have an answer in your head. I'm sure you do. But first I have a question. In what space? See, in R2, we have a circle of radius 2 centered at the origin. And the graph is what we expect, a circle centered at the origin. Now I'm going to move this over because we have this new world opened up to us. In R3, it has what we call a trace in the xy plane of that circle of radius 2. But since z doesn't appear in the equation, z takes on every real number value. So in R3, we have a right circular cylinder with radius 2 centered on the z-axis. So let's see what that looks like. So we have here this cylinder of radius 2 centered with the z-axis. And in my mind's eye here, this gray circle is the one in the xy plane. So we're just up and down the z-axis. Now you may wonder at my statement here that since z doesn't appear in the equation, z takes on all real number values. You've seen this before. If we consider, I'm going to change the color here. If we consider the equation y equals 4, you know that is a horizontal line at a y value of 4, and it takes on every x value, right? And as you see, x doesn't appear in the equation. So we're just using that same convention now in the three-dimensional space. So whenever you're asked now what shape is represented by an equation, you have to know in what context you're answering. In 2 dimensions, a circle. Here in 3 dimensions, a cylinder.